Hi, today I'm talking about LeetCode problem 953, verifying an alien dictionary. What this problem asks you to do is write a function that takes a list of words and an order parameter. The order parameter specifies the order of our alien language. So this is like the lexicographic ordering, I suppose. H is the first character, L, A, whatever. It's like our own alphabet would be A, B, C, D. The alphabet they're giving us is H, L, A, B, C, the order they're giving us. And what you're supposed to do is return true if the list of words is in the order that they supply, and false if it's not. So you don't have to sort it or anything, you just have to say true, it's in the right order, or false, it's in the wrong order. And so what I always like to do when thinking about this is try to think about how I would solve the problem, with my human brain instead of the computer brain. And like, what does it mean to think are words in order? Are words, are words in order? Are they in lexicographic order? So like a list of words is in order if all of the elements in the list are less than or equal to their subsequent element all the way to the end. So like this list I have would be in order because every element is less than or equal to its sub-elements. So 0 is less than 1, 2 is less than 3. Okay, how do we apply that same logic to words? How do we say the word 1 is less than the word 2? This is really just like, how do I put something in alphabetical order? And when thinking about this, I realized, the alien dictionary part of it, the fact that it's going to be a random ordering, it's kind of an unnecessary complication. If you can write this to order things according to our own alphabet, just take the alphabet as a parameter, then you can order to any arbitrary alphabet or any arbitrary ordering. So just thinking about it with our own alphabet will just help make things simpler and more intuitive. I was considering a few different cases. Well, what if the words are equal length? What if the words are unequal in length? What if the characters are the same? What if the characters are different? So what happens there? So if the words are equal length, we're just going to iterate over each of the letters in the word and make a comparison. If the words are unequal length, we want the one that should be lesser than the other. We want what should be the smaller word to be the shorter word. So like in this example, the word A would come before the word AA in a lexicographic ordering because A is shorter. So if the word lengths are unequal, we're in order if the first one is small and the second one is longer. If the characters are the same, when we're making our comparison as we go through the letters, if the characters are the same, we just want to continue on comparing them. If the characters are different, then here we can say, okay, potentially we're going to prove or disprove an ordering. And how we're going to do that is, okay, let's say, we're looking, let me use a different color. We're looking letter by letter. So we're comparing O to T. Okay, how do I know O is before T? Well, I look in my order list and I find the index of O. Okay, find the index of O here. And is that smaller than or equal to the index of T down here? In this case, O is less than T. O comes before T. So I would just keep going. No, sorry, I wouldn't keep going. O is less than T. So there's no need to keep going because I've already proved this case. That's actually a mistake I made when originally trying to implement it. I was like, okay, I've compared this letter. Now I'm just going to go through the words and make sure every letter is like that. But of course, you don't need to do that. If this were TAO, tau, 1 would still come before it because O comes before T. So you don't have to make any subsequent comparisons. So I'm sure you know how to alphabetize things, so maybe that was a waste to explain that. But it's just helpful to review the logic and make sure you understand it as you're going in to try to write the program. As I mentioned, when I first looked at this problem, I just kind of jumped in and just kind of intuitively wrote what I thought was alphabetizing things without really thinking about it, and I wound up doing something that was illogical. Whereas if I had thought about it first, I did think about it subsequently after I failed the problem, but if I had thought about it first, I would have written the correct logic the first time. So let's see. The definition, for is alien sorted, this is the method they want us to write. The first thing I'm doing is just creating a dictionary. And this is just to easily look up the place in the alphabet. So you don't have to use this. I just thought this would be a bit faster than searching my order string for the index of each character whenever I wanted to make a comparison. But what this dictionary has is a key for each letter in my order string. And the value associated to that key is its place in the order string. So the first letter in the order string has a value of 0, the second letter in the order string a value of 1, and so on. And I'll just use that to look up whenever I'm making one of these comparisons, are these two letters, which of these two letters comes before the other one. The next thing I'm doing in this function is I'm going to go between, or I'm going to iterate between 0 and length of the words less than 1. So however many words there are, 1 less than that, I'm going to iterate through 0 to 1. And the reason for that is I'm going to get a current word, which is the word at my current index, and a next word, which is the word at the next index. And I'm just going to check to make sure that current comes before next. And if current comes before next or is equal to next, then I'm just going to keep going. If that's true for every current and next pair, then my list is in order. And if it's not true for any of them, then the list is not in order. So the next thing in my list, or my loop, says if the word is less than, then we're going to continue. So if cur is less than or equal to, next we're going to continue, and otherwise we're going to return false. Another way to write that would just be if it's not true, then we would return false. And maybe that's a bit simpler. And if we've made all of these comparisons and we never hit the return false condition, then we're in order and we return true. And it's also worth thinking about here the kind of special case. What if we only have one word in our dictionary, or in our word list? Would this work? Well, yeah, because one word is always in order. So this loop wouldn't run at all because it would be going between 0 and 0. And then we just return true. So one word is always in order. Same with an empty words list. This loop wouldn't run at all, and we'd return true. So yeah, let's dive into the word less than function. It takes a word, and it takes another word less than. And this is going to return true if word is less than or less than word, according to the order dictionary. First thing I do, I'm just going to get the length of my less than word, and then we're going to iterate through all the indices in our word. The first check we want to do is just to make sure that the current index we're on is less than the size of our less than word. Because we want to access an element in the less than word, we want to make sure we don't access an element that is off the edge of the less than word, so to speak. Or, yeah, we don't access an invalid index. This comparison is going to be if the two letters that we're comparing are equal. So if we're comparing A to AA, then the first comparison we make, these are going to be equal. So we're just going to continue and keep making subsequent comparisons. Of course, in this example, then we'd be done with the loop because we'd be looking at an index that's greater than the length of our word. And if we were done with the loop, then we'd just return true here at the bottom. But if we weren't done with the loop, if we compared and said, okay, the first letter is equal, then what would we do? We'd hit the next execution of the loop. Let's say these letters aren't equal. Well, if they aren't equal, we're just going to check to see if the less than letter is greater than the word letter, according to our order dictionary. And if that is true, we're going to return true. We found a case like the O is less than T, so we don't have to make any subsequent comparisons because we know that the current letter is less than the other letter. Yeah, and if we ever find a case where like we've kind of run off the end of the less than word, so we've compared all the letters in, I guess this is kind of the opposite case, where we have AA as our word and A as the less than word. So we compare here, we say they're equal. We try to compare when index is 1, which is obviously not less than the length of the less than word, which is 1. So we'd try to make this comparison, and then we'd return false. And that's what you see here. If we ever reach a place where this check didn't happen, then we'd return false. So let's run this code, see if it works. I hope it will, unless I broke it by changing this to not. The test cases I wanted to run, let's see, I originally wrote this on a different computer than I'm recording it on, so I don't have my test cases here. But the test cases that I would like to run, it's always good to run the example test cases, and then see if you can think of any other ones. So other test cases I'd like to run, I'm not going to type them out here just because I don't want to type test cases while recording the video. But other test cases I'd like to run would be, okay, I'd like to see the maximum constraints. So what if we had a really long words list? Is it possible that this is somehow slow? I don't think that's important here because this seems like a pretty efficient algorithm to me. Want to make sure that we have the maximum word length. Again, I don't think that'll matter because this seems performant. I guess most important would be we want to check the case where it's in order, where it's not in order, where say the first 2 or the first in elements are in order, where they aren't in order. Where a disorder occurs in the first word, but everything else is fine, or when you have many words that are the same, or when you have a list of just one word or no words. I'd want to put in edge cases like that to just make sure that I'm not going to run into an edge case when I actually submit the program. But as I mentioned, as you can see, it's fairly performant, 92% for speed or 92 percentile. There's probably ways to make it even better. But what I guess what I mostly learned when working on this is what I was talking about before, to really work through the logic yourself before trying to implement it. Even if it's something simple like alphabetizing words that you may think you intuitively understand, and you probably do intuitively understand it, but unless you've thought about what that algorithm is, it's easy to implement it incorrectly. And the other thing I kind of took away from this problem was when I was trying it originally, I thought I could be clever and use the sort function. I thought, oh well, I'll just write. So Python lets you sort a list and supply a key parameter, which is a function that will evaluate the members of your sequence and put that sequence, or rather return a sequence that's in order according to your key. So I thought, oh, I can just be clever and sort the words, use the sort function. I'll just write a little function here to alphabetize words, and then I'll just say, is my sorted list equal to the words list? But that wound up being a little harder than I thought, and I did that incorrectly once or twice. So if you look at my submission history, I did that incorrectly last night when I was trying it, and then when I woke up this morning, I said, okay, I'm not going to try to use a sort and be clever. I'm just going to implement it, the way I would think about the problem, or the way that I would do it. And that wound up being not only a workable solution, but a pretty good one, I think. So if you enjoyed this video, let me know. Click the like button, say something in the comments so I know you're watching. And if you want to see me solve a LeetCode problem and walk through it, please subscribe. I'm going to try to do that about once a day. Thanks for your time. Bye-bye.